Hello, welcome to the third episode of our CosmWasm workshop. In this episode, we're going to be attempting something that we have only cobbled together in the last day or so, which is to be collaboratively coding a contract. The contract, get your excuses in early, as they say. The contract is Callum's own devising a tally-based voting contract, and we're going to pick up where we left off, which was using the template example from the CosmWasm template, the counter contract, which you may remember. And we're basically just going to rip it apart, get rid of the stuff we don't need, and in the process, build out and show you the pieces that we're going to add in to make it do the voting thing that we want to do. Okay. So first of all, I'm going to get up my editor and try and do it without doing the infinite screen thing where you just show an infinite regression. That's not possible. Okay. Whoop. Okay.
Nice.
Callum, can you see my editor on the screen?
Yes, I can.
Excellent. And I'm guessing you can still control it from your end.
Yep.
Looks like
I'm clicking
Excellent.
about. Yeah.
Okay. So what we're going to do here is build out a simple polling application. And like we talked about in the previous episode, we're going to kind of go through the different main entry points that we care about in order. So in this very, very simple contract, we have an instantiate endpoint, entry point, execute entry point, and a query entry point. And those are the three that we care about. And we'll go through them in order and then build out the functionality from there. So and I'm gonna throw this over to Callum in a second because I don't know if we both work the same way. But personally, I tend to, when I'm working on some new functionality, think about what the contract interface should be first and code out something in the message namespace, message.rs, which is the conventional name for where messages get stored, the structs that represent the JSON that's passed over the wire. I tend to write that first and then move on to the actual implementation because I find that it helps the design process to kind of do it that way around. But I don't know, Callum, do you do it a different way?
I go state to message. So I describe the underlying state and then the interface with the state. But we can do the message first. I'm not that bothered by
Interesting. Yeah, okay. I mean, that either one works, I guess. So, but we've got message.rs open, so
yeah,
I guess we'll do this, but then we're going to have to obviously change some state as we go. So the first thing we're going to need to do is establish what instantiate arguments should be sent to the contract. So Callum, do you want to explain what arguments we think should be sent?
Yeah, so there is a case here that you might want to put some sort of root contract admin on this polling app that may have the ability to delete a poll. This sort of makes sense where you could have, as the contract will store multiple polls. We want someone to be able to sort of moderate and delete the poll. And in this case, as Fred's typing out, this admin address will be a string because if you don't know, misleading about the ADDR type, the address type, is that it's not actually validated. So we're passing it a string, so you can put any string there, and we're going to validate it on the contract side, and we'll throw an error if it isn't a valid address. And exactly. I think that's all for the state, I imagine. I can't think of anything that sticks out too much, and then we can just probably remove the count.
Well, we should initialize. Oh yeah, we don't actually. Yeah, we don't need.
We can just always initialize it to 0, can't we? Yeah. So yeah, we're jumping a bit ahead, but what we're explaining there briefly is that polls will be uniquely identified by a numeric ID, and we're going to keep track of a counter that will just always be going up. So the first poll will be ID 0 because we just index at 0, and then the next one will be 1, 2, 3, and then it just goes up until you hit the U64 limit, and then the polling app falls apart. If someone's making the U64 limit polls, you're probably under attack.
Yeah. So that incidentally probably is a case you want to think about as a contract author. But the other thing to bear in mind, we did, I think, mention this in the last tutorial, is that in these JSON serialized structs, if you use the triple tick notation for writing a comment above the key that you're defining, when this gets serialized to JSON schema, which is a kind of, well, it's a schema, as the name suggests, for defining what the contract interface is here, it will actually save that into the description field of the schema, and then that will persist onto other things. So I noticed we had a question earlier already in the chat saying, how do you use those schemas in a front-end application? Well, our very, very smart friend, AS Weaver, uses QuickType to actually generate TypeScript definitions based off of the JSON schema. And the tools like that will also collect the description field from the JSON schema and then put it into the JavaScript TypeScript file that's created as a comment. So writing these comments, while perhaps tedious, means that you tend to have a portable description that's kind of moving around explaining what this thing is. In this case, this admin address is quite self-explanatory, but I guess the only thing maybe that you'd want to explain about it that we haven't here is that it's an admin address for specific functionality on the contract, but it's not actually confusingly, it's not actually the admin field that can migrate the contract. That's a separate thing. We won't be touching that too much.
Yeah, we won't be touching that until if this carries on way down the line. But what I like to call, just to reduce confusion, is I call the WASM admin, the one that can perform migrations, the root WASM admin, whereas this is internally defined logic for our admin. Like, this is what we define, whereas we are bound by the root WASM admin that the WASM module spec requires. Well, it doesn't require it, but you have to set it to null or actually an address.
Yeah, you have to pass no admin if you don't want to provide one. Okay, so we've changed this instantiate message. So if we save the file, it's going to I think this is, I'm still quite, I don't use Visual Studio Code, so I think these are now files that are complaining.
We've broken
it, which we should have done, because
yeah, that's perfect.
So right, yeah, it's saying, I think it's saying this does not exist. Yeah. Okay, good. So what we probably want to do is we're going to change this state object to do, and in fact, actually, I kind of hate the name state as well.
Yeah, can we change that to, shall I change that to config?
Yeah, we should change that to config, I think.
I think both jump over to the state file, because I feel like this is a good bit.
This is a good way around. You're right. Let's go over to the state file. So we can see here that it's already defined with a couple of fields that we actually are not relevant to us. So we called it admin address.
Yeah, and make sure you store it as an ADDR now. Yeah, because that's now validated. So I'll put a comment.
Excellent. So this just means that we can validate that the string is the correct format for an actual address. Kind of nothing more than that, but it's useful to just bear in mind that when things come in over the wire, i.e. from like a front end, they're going to be in one step. Oh, it's blooming insensitive. It's case insensitive matching.
He tried to be too smart. He ran before he could walk.
Yeah, and that's annoying. So we're going to recall it config.
Oh shit!
Well, we did say that there's going to be some swearing in this talk. So there we go. Okay. Well, via the process of infinite monkeys and typewriters, I think we are now there. Okay,
so this file is no longer erroring.
that file is no longer complaining. So, and then we probably want, in fact, oh yeah, it's going to be something like message address. Oh, it knew that was what we were trying to do. Excellent. Very good.
I'm
and you can
quickly
see,
patching up imports to try and.
yeah. So what Callum's done here is renamed the struct literal to be config, just so that that's correctly done. Below it, we've got set contract version. We don't need to change that because that's just what gets set. If you look in mint scan, you'll be able to see that being used. We will change the name of it from here's one I made earlier to, actually, no, we don't have to change it because that's kind of what's called in the folder directory. So we'll just leave it. But
let's not break that.
But if you, this is basically, this field here is what will get saved on chain as the metadata for what the contract is called, right?
We also need to actually validate the address. I've just realized for the reasoning we gave. So this is what I'm now gonna add using the.
Ooh, don't do it in line. That's naughty. Come on, be cool, man. There we go.
So this line above, I'm now going to validate the address. So the dependencies mutable has a helper literally called under the API, just address validate, and you have to give it the reference to a string. So you just need to prefix it with the and then this, the return type of this. The return type of this is an STD result of address, so we can unwrap it using a question mark. And this means this type. Mine doesn't show type annotations because I'm remoting in, but I don't know if on the stream it should now show the type of admin address as address.
Yeah, so admin address is going to be address down there, and it's also, you can see here if you hover over this that the deps API adder validate returns result of adder over standard error as a result type, which I think we mentioned on the previous streams is kind of like an either type. It's a monadic response, basically, which is all very, very clever ways of saying it's just a very good way of handling errors and things that can be chained together. And whenever you're in a result type, you can use the question mark shorthand rather than calling unwrap and seeing what the unwrapped value inside the monad is, where the result is a monad. So all this is actually doing is saying, look, okay, we're in a result type here. The instantiate function returns result over response and contract error. So if we have another function call like deps API adder validate that is itself returns a result monad, we can basically short circuit it with the question mark and say, okay, well, we're in the same context, we're in a result context, and via the power of algebraic data types, we're just going to give you a bit of syntactic sugar to say error out of this line. It's also an interesting point to consider, and I think again we've mentioned this before, that when you write unit tests for this stuff, because they're just Rust unit tests, if you modify behavior and then you hit a question mark or a result type, if you like, the errors later in the function you're testing, state will be persisted from earlier operations, but that behavior wouldn't happen on chain, because on chain these are all of these functions are executed atomically as a transaction. So if anything within the result fails, it fails out the whole thing and doesn't do any state modification. So, actually, is that true of all result types? That might be true of all result types, but the key is that it is actually possible. Yeah, no, that's true of all result types, I think, actually. So it's just possible. It is possible. Actually, no, wait. I'm tying myself in circles here. I think it is possible, actually, even within result type, to modify state potentially inside Rust, because it is just imperative. But you will find anyway occasionally a weird edge cases that you can modify state in a unit test and it will do one thing and it will do a different thing on chain. So just write your unit tests accordingly, write your behavior accordingly. You're probably not going to run into that anyway. So right, we're saving the state, which is just this admin address, and then we also need to save a counter in there, don't we? Or do you want to add that as a different item?
Let's do a separate item, I think.
Separate. It's going to be a separate item. So let's go back to the state file.
Yeah. And just a quick comment on what I just corrected in the contract. I the config was still pointing to the message.admin address. I just made it point to the actual validated one. And what that shorthand there, you're like, why is there not a colon? It just that without a colon is equivalent to this. And quite often your linter will scream at you and be like, you can just shorten this. It's the same in JavaScript as well, like any sort of JavaScript TypeScript language. So this is just shorthand initialization where just the field names match. So they just expand out. A little bit of syntactic sugar. So yeah, and then we just want to, once that is corrected, we can jump over to the state and start defining the other counter.
Yeah, and then we just need to
trim down the errors.
So actually, I don't think we need this entire.
Yeah, drop that line, and then that's all we need.
This just needs to be. It'll be just, which I think will need clone.
I think the one in the config will need cloning, I believe. So the one up here.
Yeah, I think that will need cloning.
But now I've unexpanded that because we need to clone it and get a deep copy just because of how Rust does things.
Yeah, so essentially what's happening here is it doesn't implement the copy trait. So we need to just create a copy of the admin address so that it's available because it's being passed out of scope into a different closure. Which don't worry about too much. Your editor will normally complain about you about that. Rust format or Clippy will also complain about it. And the Rust compiler will save your bacon. So should we go and add the state?
Yes, let's do that.
Okay, so we're going to add another item, which we're going to call, what are we going to call it? Contract number? Counter
ID counter.
ID counter. See, naming things is hard. ID counter item. It's going to be item over U64 because we just want a numeric type. And it's going to be, again, a item new from CosmWasm. And we're going to give it the key ID counter because that is what it's called. And I'm not imaginative. So there you go. Create the item of type config under the. These good comments. These are good code comments. They're better than my code comments. So can you see? We mentioned this before. You can probably see we're about to go with this item of type U64. Okay, cool. So now we're going to import from state. I'm going to import ID counter. And if we complain, it's going to say it's not actually been used. But that's okay, because we're about to use it. So save the ID counter. ID counter.save. So we're just going to initialize this to default value. And
just be at 0.
You can just do that, can't you?
Yeah, I see that. I
always forget that. So this is actually, funnily enough, this is literally a mistake I made this morning, where I think I had something that was initialized to a numeric type, and I was using unwrap or default somewhere to define its return value into a contract, into the contract whenever it was called. So it was being very fault tolerant of the fact that actually in a different scenario it was not actually set yet. But then when I started using it in unit tests, I realized I'd never actually set it to a default value. So it's a good idea if you've got anything that's stateful like this that should have a kind of default setting value. Just set it in config or in your instantiate hook when you instantiate the contract. Otherwise, it might make your life a bit difficult, or you'll get a bug like I did. Okay, I think that is everything we need for the instantiate method, isn't it?
Yeah, that is.
It's sort of screaming about something. Oh, okay, there's tests.
It's all the methods down below and the tests. Like we can probably get away with deleting the mod test and just re-adding it later.
I'd say let's just fix the tests. There we go.
Well, yeah. Well, that's a lot of the errors of this file gone. And then there's just the old methods of like the old query routes, which we can get to.
There you go.
And these ones can just go to the bin because they're not used. The ones above, so I'm going to undo that just because they didn't see. I don't know if I can. Oh, I can. So these ones are specific to the generated contract. There's try increment, which just increments the count, but which we'll do internally on a new poll creation. So we don't need an endpoint that does that. And try reset resets the counter, which we will never do because that means we could have clashing IDs. So yeah, that's why I'm just deleting these.
You can fully delete those. Cool. And actually, let's delete this one as well because probably don't need that. And we can just re-implement it if we want to get a count of all the polls that we have, which we probably don't ever really need to expose to a user, to be honest. So we don't need it. Right. That's all of our instantiate method, instantiate function done. So what we've done so far is we've basically just updated the config hash to be called config. We've made it so it has an admin address, and we've added this ID counter, which we're going to increment every time we create a new poll. We haven't actually implemented the poll creation endpoint yet, which we're about to do. So, oh, and since there's some integration testers are also complaining.
Yeah,
to do those too.
This is not our true policy for testing.
Yes, by the way, always write tests, always fix them as you go. We're just cheating because we're doing a workshop and we need to move relatively quickly. So we're going to delete what is here. We don't need it. And we're going to define some new execute functionality. So first of all, we want to do create poll. And then we want to do vote. So create poll, we are going to have a question. So for the purposes of this, again, because we're doing a very simplified, we're going to do a very, very, very simplified polling application. We're not going to have multiple choice. That again, if you would like to do that, that can be an exercise to the reader. We're just going to have a single question with a yes/no response possible, which is going to lead us to our vote, which is going to take a poll ID, which is a U64, so the same type that we already defined as identifying uniquely our poll. And we're going to also take the vote, let's say, which is going to be an enum, which we haven't defined yet. So this is going to be a vote. Yes. Because why not overload the word vote, vote choice? Let's call it vote choice. There you go. It's just, and then we actually want, so these derive bits at the top, don't worry about them too much. They're Rust macros, but what they're doing is defining things that help us with JSON serialization and deserialization. So we will need that for the enum we're about to define, which we're going to use in this function here. So while Callum writes some more comments, I'm going to go and define this enum vote choice, which you can see is complaining down here. It doesn't exist. So vote choice. And actually in a minute, we're probably going to move vote choice to state, and you'll see why in a moment. And we
have two enumerations.
We want yes.
You don't need pub here because it's not struct. You can just do capital Y yes, and then that'll be made up of nothing. It'll be just literally a boring enum.
Yeah, I think it'll literally do that, won't it?
Yeah.
So notice the enums can have some sort of additional, but they can essentially have structs as as sort of keys, if you like. So down here, this execute message is actually an enum, where it has these kind of substructures to define what things are. And actually, you can also refer to them with a kind of tuple-like syntax to also express that the definition lives elsewhere. For the purposes of this, we're not going to do that. In this case, we just literally care about yes and no. And this will be from memory in JSON. This will be.
It should be all lowercase, the string, so it should be no.
So it should be no. And that's how this is how they get serialized, basically.
And if you had multiple sort of words like I don't know, that would be serialized as I don't know, because of the Serda rename all snake case, where it renames all of them when they're serialized to snake case, but we don't need that.
Yeah, exactly. So a very common thing you'll see this used for is something like range queries within CosmWasm, where you might have something like ask and desk, like ascending, descending, and then you'd have like ask, desk. So this particular example is a bit dopey, but it's definitely something that you do see in the wild and will end up using. So we've defined vote choice in message, but we actually don't want it here. And that's because we're going to use it elsewhere. We're going to use it in state too. So it's better for us to define it in state and then import it here. So we're just going to go move that over to state. And as an aside, you'll sometimes see things like this defined if you don't actually ever need to. We can actually remove the snake case bit, can't we? Because it's only simple.
Yeah.
So it's usually only if you have, like Callum said, longer multiple camel case or Pascal case things that you want to have the snake case. We don't need that right now. So because they're only a couple of letters long. So the reason that you might just leave this in message is that, for example, in this case here, this is actually quite common actually, that you see there'll be something like config JSON, which will say admin address string and live in the message.rs file. Whereas the actual config struct will live in the state file with a type of adder, because adder is what it's saved to in storage, but what it comes in as over the wire is a string. Okay. Although, yeah, that's a little bit by the by. So we've now got that. We need to import it. So you can do use create state. And what do we just call it? Vote choice.
Vote choice, yeah.
Cool. Contract is screaming at us, and we'll get to that in a minute.
Yeah, that's because we deleted all the messages.
Because we've deleted absolutely everything. So I'm going to write the comment first to describe what we're about to do. So we're going to create a mapping of, wait, what are we going to do? We're going to create a mapping of ID
to poll.
Okay, so this implies that we need a poll struct. Now, Callum, what does a poll struct involve? Do you want to take over for a minute?
Yeah, so the poll struct, as we defined, our polls will be very simple. We have a question, which is a string, and then are we just going to store the vote counts on the poll struct itself and just write to that when we need it?
Yes, I think we'll just store it.
So we can just have two variables called yes vote, which is a U64, and a no vote, which is a U64. Which we can just increment and decrement appropriately. So yeah, and then we can also have the question, which is up here, type string, quest job.
Oh, okay. I tried to do Try to do some sublime magic and put 3 cursors at the start of the line there, and it didn't work. So there's no multiple cursors. Oh, damn. Okay, cool. That'd look cool if I had been able to pull it off.
Yeah.
It's going to just magically drop the word pub in front of all 3 of them. But
yeah. So the pub just means that we can access it from outside the context of the struct itself. So we'll just be able to instantiate it and read it as we need it. This is just quite common. Then just keep it public, makes it simpler. No getters or setters here.
Yeah, there's actually very few cases in the context of CosmWasm contracts that you want to make things not public, I think. But yeah, I really can't think of one right now. So
no, I haven't used one. It's all publicly readable on a blockchain, so it's not like you need like privacy because you're sacrificing that.
It's not like you need privacy. It's just a quote for the 80s, isn't it? Okay, so
this is not my actual view.
Should we call it polls?
Yeah,
seems like what it might be. So we need to define the type of this map before continuing. And as we said, it's going to be a mapping of the counter that we're already using. So we know that that's a U64. And we know that the value of it, as Callum's typing, is going to be poll. So we know that that's the type of it. And then it's just a, can you guess it? It's a map new. And let's call it polls. That's quick and efficient typing. Excellent.
And we need to import it above.
We are going to need to import map.
So you just modify the storage plus import to just include both, which means adding those braces, which is just the syntax for importing both. And then you can just add map in a comma separated list.
Cool. And then save the file, and it looks like it's not complaining about anything. So that means we are now ready
to move on,
to go and create a poll. So we now need to, so we've got create poll, which takes a question, and we've got this poll ID and vote type in the messages. So we now need to go and implement the messages that correspond to create poll and vote, which we will do now. So previously, Callum's already there. So previously we were working in this entry point instantiate, which you can see here on line 14 and 15 starting. And as we said, the 2 other entry points we care about are execute and query. And these are going to exist under the execute endpoint. So saying create poll question, that is correct. And then we are going to do vote, poll ID vote type.
Correct this, it's auto-filled wrong. There we go.
There you go. And it's also, you see it's also just type hinting here for you.
Because we're not using them, it's screaming at us.
And also apologies for the fact that it's in order to blow this up big enough to actually register on the stream, it's sort of wrapping off the page. And I don't actually use I don't use VS Code as my editor, so I thought I had set it to wrap at 80 characters, but obviously I haven't. I've obviously screwed that up. So sorry, viewers. We'll just have to scroll over to the right to show you what we're doing occasionally. So I apologize in advance about that. So we're going to now have to implement a couple of execute functions for this behavior, which let's call them. Why not? Pub. Actually, do they even need to be public, do they? So we can just be fn create poll. Why not? YOLO. With some arguments, with a return type. And then we'll do fn yes vote. We're going for the original namings today. So the normal response type is response over
it's result contract error.
Yes, sorry, it's result over response and contract error. It didn't complete. That's annoying. Okay, there we go. So that's our expected type, and we can probably stop it complaining by doing response default.
I'll wrap it in an OK. Yeah.
Yeah. And then that should hopefully stop the compiler complaining. There we go. And then we can then, for each one of these, do create poll, and then it's going to take, let's see here, say question, but it's also going to take some other arguments. Now, those are the context of, well, I guess you can think of them as the context of the execution. So because there is a kind of, I guess, a loosely functional style happening here, we have to pass in dependencies that are used for so we have to pass in dependencies that you use for things like storage, like state modification. So you can see what those are actually called here. So in this case, it's deps mute, env, and info. So if you need to access, for example, the sender of the message and know who they are, that's in message info in this struct, which you can go look. And then the message itself is this message type. That you can see here, we're actually destructuring using Rust destructuring syntax to get at specific keys. But you can also pass the entire message if you just want the whole thing, and you can then work with it however you like later. For both of these, we are going to want deps.
Yeah, as that contains the storage which we'll need to write to state. And I don't think we'll actually need env or info, because it's kind of going to be permissionless, isn't it?
It's going to be permissionless. So the final thing we'll say before we move on is that an exercise to the reader on this code and what we've done is that you might want to actually so this poll is just going to go forever, right? Where you create the poll, you can vote on it, you can tally the response at that point, but it will continue forever. So in order to stop, to have an end date, you would typically use a block height or a Unix timestamp, and then just say after that point, it's essentially locked. You can't vote on it any longer, and you can only, whenever you tally, you just get a final response and maybe an additional piece of data saying the poll is closed, right? A piece of metadata to indicate that it's finished. We're not going to implement that. But if you did want to implement it, and we recommend you look into this, then you will need to look at this env guy here a bit more closely, because the answers that you seek are contained within that struct. So with that, with that somewhat dubious clarification, we're ready to go. So let's stick in deps mute and question. Okay, so excellent, Callan's done that bit down there. So what do we need to do in order to create the poll?
So we actually don't really need to perform any validation. We're just going to assume the question is valid, and we just set yes or no votes to 0. Which could be an awful mistake, but this is just for the context of this example.
Yeah. So first of all, so we know that polls is a mapping of U64 to, of U64 to a poll. So we need to create a poll struct, and we also need to create a identifier for it that is unique. So there's two things we need to do. One is use that question to create the question part of the poll struct, but the other bit is that we actually need to know what our numeric identifier is going to be. So the first thing we need to do is look up the numeric identifier before we can start to construct this poll struct. So what we need to know, what is the current ID? We will use that as the key in our map. So we need to look up ID equals ID counter mode. Oh, I can't spell.
Yep, and unwrap that so it contains that variable now is the U64, which we can just use, and then.
Yeah, so we once again use the magic question mark to make that happen. Otherwise, you'd have to unwrap it. And it's also worth knowing that you can use mayload to get an option type back if you want to kind of handle your errors and whether or not it exists yourself. But we already incremented it. We already initialized it to 0, so we know it should always exist. If it doesn't exist, your load there will throw an error where it will say, it will throw a base error from CosmWasm. I can't remember the exact one. I think it's a query error, and then it will say U64 not found, something like that.
Yeah, I think it'll have the storage key as well. It'll just kind of completely error out and sort of tell you like, oh, it's meant to be here, but it isn't.
Yeah, so what we're going to do is we're going to use that ID in our poll, and then, so poll save, depth storage, then we are going to use current ID as our key, and then we're going to use the poll as the value. And then afterwards, we need to increment the ID. So the next time this is called, it is a different number, exactly as Callum said there. So, and then I'll do yes.
Yes underscore votes, I think it is.
Is it yes votes?
Yeah, I think so. I'll check the state. Yes, it's yes underscore vote. It's singular. So I'll add S's to them because there can be multiple. There we go. That should fix that for you.
And I think we can actually just do that, in fact.
Yep.
Ooh,
and we need to import poll, which I'll do at the top.
There you go. He's importing
because
it.
Sometimes the automatic imports don't work because we're streaming it. So there we go. I've just added those.
Yeah, I think the development environment is a bit smoother when you're not streaming this. Consider borrowing here. Yes, okay, that is a good point. Thank you, compiler. It's still expected.
No, well, I just added that semicolon. Oh wait, have we not saved the file?
Oh, we didn't save
Control
the file.
S and pray.
Okay, cool. So, and then the final thing we need to do is then increment the ID counter.
Yeah, so there's actually multiple ways to go about this before we jump in, maybe. Is the first one could be, if you're similar to other languages, you could make current ID mutable, and then
don't do that. Don't do that.
Yeah, but you could then just do current ID plus equals 1. This isn't the rusty way to do it, as mutability bad in any functional programming language. This kind of rule 1 of functional programming is, mutability bad, boo. So we can actually call a helper on the ID counter called update, or we could just create a new variable for it. There's actually 3 main ways to go about it.
Or we can just straight up save over the top of it as well.
Yeah, that's what. So there's the update help. There's mutability. Try and avoid that. There is create a new variable of which is just current ID plus 1 and just called .save, which is very similar to what we've seen before, which we'll just demo now because we can switch out. We could even comment out one and the other, and just they're both practically the same thing, but there might be a slight bass optimization there. But if you're optimizing at that level, you should probably just have a day off. And yeah.
Okay, so this is as Callum mentioned, this is one way of doing it. And then of course you can question mark. That's one way of doing it. Another way of doing it would be to use update. So Callum, do you want to show how that works? I wonder if it's going to help with any auto-completing. But it's essentially
it is, but
you kind of see, oh wow, that was actually quite impressive. So what it essentially does is it you pass in storage, and then you pass in an anonymous function, which Callum's defining with those two pipes, which that anonymous function needs to return a standard result type. But whatever is contained within the OK, i.e. the accepted, the success branch of the result monad, will be the updated value of the thing you've accessed. So this is less useful in the case of what we're doing here, which is just an item, which is a scalar value. It's not a big deal. But the place this is particularly useful, for example, is hash maps or something like that, because then in your anonymous function that we've defined here on line 79, or that Callum has defined here on line 79, you can do quite sophisticated, kind of arbitrary complexity logic here in this closure to define whether or not it actually should be updated or not before returning your OK. So it's quite common to see something like that with like a match statement inside to define whether or not an update should take place. That was an odd comment before you changed it there.
Yeah.
Cool. So I'm going to comment out this top one just so it doesn't error because we're doing the same thing twice. So generally speaking, if it's a scalar singular thing, you can probably use the save notation we used above, and if it's like a hash map, you want to use update. But we'll leave the update one in because it's a bit fancier. Yeah, why not? Let's treat ourselves.
We're flexing on you guys. Come on, like we know what we're talking about.
It's a Wednesday. We need to treat ourselves a bit. It's midweek. So now the second thing we need to implement is voting, which is going to behave very similarly. And again, you can probably guess that we're going to be looking up the poll by its ID and then calling that up.
Oh, this is actually a place where you would use the update.
It is. It's almost like
I thought
of this 5 minutes ago and was just looking for an opportunity to copy and paste the previous code.
Yeah, nice.
Because that's how we roll. But you'll see what I meant in a minute about how we're going to use that closure to change the struct that we had. Okay. So first of all, we load the poll ID. So we're again going to rely on the fact that the question mark notation will error out.
Yeah, we don't need to check if it doesn't exist because the code will panic for us.
Storage.
Yeah.
It doesn't actually need to be borrowed, I don't think.
No, its storage is quite nice.
And then poll ID will rely on that existing, and then we'll error out.
Yeah, and I'm just going to quickly explain a flaw in our model. We don't track who's voted on what, so you could infinitely vote on a poll. But that's a feature, not a bug here. You know, if you want to botnet a poll on chain, go for it.
Yeah, exactly. So again, how you would track that is essentially you need to make an additional map of who's actually voted on what and track some additional state. We're trying to keep it super simple, so we're not going to do that here, but you can see that would very quickly become a problem. And like we can kind of going through, think about those things as you go, because there are a lot of people with botnets. There is, of course, there's the stealth whale, there's the micro whale. We all have to be worried about these guys. I'm not imagining things. The micro whale is real.
They're real. They are real, and they're
coming for you.
They are coming for your polls.
The micro whale is real and does care about messing with your poll. Okay, so we're going to do polls update here, where we're going to do store.storage, same as before. But here, something slightly different is going to happen, which is that we are going to look up the ID. Yes, correct. What do we call it? Poll ID. And then we are going to take an action over the poll.
Also, I just realized we don't need that line above because this poll type will be an option poll because we're doing it on a map. If you look. So we can have a unwrap or error, which is something we can get into here.
You're right, we can do that. So let's remove that. Callum is correct.
I'm going to remove that code. Just to...
Yeah. So what we're going to... Oh, hang on a second. We should have probably added some response attributes to that response, shouldn't we?
Let's do that at the end for both of them.
Yeah, okay, yeah, because we can just copy and paste, can't we? Yay, copy and pasting. Okay, cool. So we need to... Oh, right, so we need to do a match statement here then, don't we? Basically.
Or you could do a destructuring if statement, but it's whatever floats your boat.
So some P, that's kind of...
Come on, let's use name shadowing here. Let's flex for us. Let's do some poll. Come on.
No, name shadowing sucks. I don't like it.
Do you not? I love it.
It's kind of a code smell, actually. It's not... Well, it's not super uncommon, I guess, among some functional languages, but it's obviously... It can lead you into weird places in terms of the understanding of the code, I think. And I personally think name shadowing is a code smell. That's just like my opinion now. But I try and remove it where I see it. The only place I don't really mind it is unit tests. So what do we do here, Callum? Well, that means the poll exists, right? Which means that we want to do...
We want to check the vote and increment the correct counter.
That's right. So we're
going to get a match within a match, aren't we? Yeah, we are.
Yeah.
Which is super common actually in Rust. That's all Rust code is, especially contracts, because you have to match within a match, but they're all just hidden in different functions.
Actually, this maybe is better expressed as an if-let.
Yeah, that's what I was thinking for the none case, because then you could just return early.
Because we don't care about the case in which there's none, do we?
Yeah, I realize we can change this to a result type to make sure we can error nicely. There we go.
So it would just be if let sum p equals poll, right?
Yeah.
And then this is where we'll let the magic happen, because we still need a match.
Yeah.
So do you want to take over here, Callum, with what we need to do?
So this match case now will be for the vote choice. So we need to enumerate over the vote type, which is passed through at the top of the function. And as we know, this can be vote choice yes. And we want to do something here. I'm just going to put a quick little to-do macro just so it doesn't scream at me too much. And vote choice no. And these will do separate things here. And there's actually a way we could... Oh, no, there isn't. Now we'll just do it. We'll do it. Sorry, I'm just thinking it. So once you're in this, so we've now identified, is it a yes vote or a no vote? So we want to expand out this body. And I might actually... So to create a new poll, as we know, mutability bad, we can just return... This function will just return the poll that we want. So we can create a new poll, and it's going to destructure P to expand it into a poll, and then it's going to do yes votes equals P dot yes votes plus 1 and destructure P, right? Is that correct? Is that the correct order?
Yeah, you just need to put, yeah, that's it. And then stick it
and it's all highlighted red for now because we haven't done it for the no, but I went over that a bit too fast for some people, so I'm just going to go over the next bit because I did it all in one line, which some people might be like, whoa, okay. So, so the okay is to make sure it's the result type. The poll, we're creating a new poll in memory to then return. We are taking the yes votes, and this new poll, the yes votes, will be the old poll, which is P, yes votes, plus 1. And then for the rest of the values, we're destructuring the original P poll because we don't want any of the other values to change. this sort of destructuring and in JavaScript it's called the spread operator. This works in JavaScript objects as well. So this is just to fill out the rest of the values. And yeah, we should probably make it a checked add just in case. So I'm going to change that to .checked.
You never know.
Yeah, the votes are actually more likely to be an attack vector than the ID itself. But yeah,
it's still complaining.
It's because we don't have an else clause, so we need to do else error, and then we need to contract error. Right. I'm going to put unauthorized here. We can make a proper error. Is that still going to scream?
It might complain. What we got? Standard error. We could just do a custom error.
Oh, okay, yeah.
We can just do custom error, and then we can put.
Oh, this needs to be unwrapped because we're setting the value there. Yeah, there you go. That was it.
So we just do custom error, and we'll pass in a custom error string, basically. So let me think. So it would be poll does not exist, I guess.
And that's a capital S string, so you need to do a .to string on it.
Of course, yeah, it's a borrowed string, isn't it?
Yeah.
It needs to be to string. Okay.
Right, yeah.
Cool. So that little fudge there is because there are two different types of string in Rust. One of them is on the stack, and one of them is on the heap. Is that right? Is that way around? Something like that.
Yeah.
And we basically just needed. This is a fixed length string, so we needed to just convert it to string with a capital S. Because you can see here it's over. It's highlighting it as a ampersand str, which is not the same as a capital S string, but the two-string operator will make a what's the name of it? Is it string slice? That's the name of it. That's the proper name, isn't it? A string slice into a string. Cool. Okay, so that should now work. I think it's pretty much a single operation. And then if that all works, then we've got an ampersand at the end, that will error out if it doesn't work. So now we can do OK response.
Let's add some attributes.
And then we can add some attributes. So we're going to add action, and the action is a vote.
And we actually can't return any other. Oh no, we can add poll ID to it. We can also tell them what poll ID they voted on and what choice they chose as an attribute. Yeah. So just a brief thing. I think I covered this in an earlier episode, but it's quite quick to explain, so I'll go again. Attributes just sort of some little metadata to attach to your contract call, which can then be returned in the returning transaction, and it sort of gives you almost like sort of HTTP headers. It's just a nice little bit of data to sort of be like, oh, I called the action vote endpoint. So yeah, and as poll ID is a number, it has to be casted to string because an attribute has to be something which can be turned into a string. I think that's actually the spec for it. So we just need to make sure we convert it to a string.
Yep. And then we need to do this one again, which is response.new, add attribute, and then the action for this one would be create poll. And that's, I think, about it, actually. Oh, I guess we probably want to return the numeric ID as well, don't we?
Yeah.
Similar kind of thing. Right. Doing something other than what I wanted to when it okay. Poll ID.
And then we can just return poll ID, I believe it's called. Current ID is what it's called.
No, but it'll be current ID +1.
No, because we saved it before incrementing. We save and then increment, so it'll be
current ID. Next one will be, yes, no, you're right.
If we wanted to add another attribute called next poll ID, that would be current ID +1.
No, you are 100% right. Good. Okay. So now those two you're going to have to believe us, but those two are now implemented and should work. So by my count, we've about 1 minute left, which is nearly enough time to implement the query message. So let's just quickly do that, and then we'll do a couple of questions and wrap up. So get count is going to need to, that's actually from the old implementation.
Yeah,
isn't it?
let's do get poll. That's the only one we technically need to just show.
So I'm going to call it get tally purely because an in-flight poll, I think in the SDK, the endpoint is a tally, it's only a count when the poll has finished. So that implies that there will be a future implementation of that, which again we can leave as an exercise to the reader. So, and then we'll need a response, which we'll see why we need that in a minute. So it's going to be
yes votes U64, no votes U64.
Oh yeah, sorry, it's going to be U64, my mistake.
Yeah.
And then this is going to be poll ID. It's worth also knowing that in CosmWasm you have a very useful type called uint128, which you can use for things like decimals and things like that. There's a whole bunch of helpers. So yeah, if you're going to do like proper arithmetic on it, and you're not bound to use U64 by an external library, then you may want to use the uint128 type. That's just a kind of a bit of an aside, but there you go. Cool. So get tally, we'll now go and implement tally, poll ID. Just go, get tally, and we're going to need, once again,
just the depths and the poll ID.
Poll ID. And we're going to need also to do one more thing, I suspect. Although, actually, to be fair, I've noticed that I do this differently from certainly how Weaver does this, possibly how you do it.
How so?
You see, there you go. There's the answer. So I would do...
you get it to respond the struct and then binary it in the query.
And then do to binary. Just because I guess I like to have the query functions returning a really specific response. And then the binary operation happens up here. So you can see here the standard result binary is in essentially the output of the match statement. I find that very occasionally helps me spot a bug before it happens, but the result is the same because the Rust compiler will shout at you either way. So there's not really a better or worse way. It's just a preference thing, I guess. You'll see maybe quite commonly in some of the old CosmWasm standard and CosmWasm Plus contracts, you'll see quite a bit of this pattern. But I think it's more for hysterical reasons than for any particular benefit. I'm not aware that one is better than the other. I guess
one might be better than the other. This way might be better for the other if you might want to call get tally in an execute route, and then that means you don't have to decode binary. You can just unwrap the tally response directly.
Yeah, that's a good point. Actually, I think this might be slightly easier in unit tests as well. And I think you can also reuse it. So I think maybe in the who am I code, we probably do that quite a bit because quite a few of the range queries are reused. But anyway, getting the tally, how do we do it?
Well, we need to load the poll, but we don't know if the poll ID will exist.
So what does that mean?
So there's two ways. We could change our response struct and have it be wrapped in an option, which would just be null if it's not there. Or we could just may load it, which is the method we described above, and then just unwrap or default, and just if the poll ID doesn't exist, just return 0 yes votes, 0 no votes.
Yep. I mean,
both work. You could argue one's better than the other.
I think actually I'm gonna throw my 2 cents into the ring here. I've just had to think about it for a second while you were talking. I think actually the correct behavior is to error if it doesn't exist.
Will we have to unwrap properly though, or will the question mark work? I think the question mark will work for an STD.
It will throw a
result,
WASM
right?
error. So actually the question is more this, and then depth storage. So actually the argument for doing mayload is more about returning a sensible error
so
message.
that you always get an actual yeah.
So what we're going to do is match poll.
Very similar pattern to in the update route, just now it's a match, not an if let. So that sum means P is now populated with a poll. None is, of course, this poll ID doesn't exist. And then we can just use custom error again.
Yeah, and we're going to say, in this case, poll does not exist. Now, you're probably looking at the fact we've typed poll does not exist twice, and you're thinking, hold on a second, that doesn't sound like a custom error. That sounds like a general case error that we just haven't bothered to write. And you would be
yes.
Right. And I need to make it to string. So we maybe we will just very, very quickly
demonstrate writing a new error.
Enum. Found enum. Ooh. What? What have I done? What have I done?
Oh, it's because we're an STD result. It just needs an STD error. So we can actually, this is actually a different case. We can use STD error. Is it then the generic underscore error function to do this?
I think it's STD error STD, and then it's wrapped in that.
I don't usually use this struct, so.
I think it's this, isn't it?
No, but the problem is it isn't that way around. The problem is we're trying to contract error in an STD result where it only supports STD error. It's the other way around to what you're thinking. So we need to just put our string in an STD error would be the quick response.
Oh yeah, you're right.
Which
so
I think is it. I can't remember for the life of me what the call is.
Yeah. Okay. So I think it's contract error, standard error. No, sorry, it's STD error because that's from CosmWasm, right?
Yeah. Let me import that.
And then
I don't think we actually do. Yeah, we don't. That's why it might be good. Yeah, there we go. I've imported it now. We might get some helpful.
It's freaking out a tiny bit. So it's STD error, and then it's contract error. And inside here, it's contract error, error, then open brackets, and then it's not helping me out here. Okay. Easy error.
Let me have a quick little. Oh yeah, okay. So you can do this little call here, which can be any into string. So from that line above, that's what it looks like.
Let's just do that then.
You can tell we don't usually use STD error.
Yeah, so what you really want to do here is define a custom error type and return that. But we're being a little bit lazy here. So, well, we're attempting to be lazy and then actually appear to have caused ourselves more work. So, don't really know how that has panned out, but it has. So there we go. Now that is get tally implemented. So we're using mayload to load an option of whether the poll ID actually returns a value, and then we're returning match on sum of poll, building a tally response out of it, and then returning a error if the poll does not exist. And bear in mind as well, Rust syntax here, there's no semicolon at the end here, so that the last thing in enclosure will be returned. Same as Lisp, same as Ruby, not same as Python, but same as many languages. Okay, so I think that is everything we were going to do. Now, what we've, it may not be clear that we've done this, but what we've done here is we've written a polling contract from front to back with an instantiate function that saves an admin address and then without any user input instantiates an ID that will represent the poll that is saved next, but it's instantiated as 0, obviously, because none exist yet. We've created 2 execute endpoints, one for creating a poll, one for voting on it. And we've created a query endpoint that will allow you to look up the votes that are there. So the couple of exercises you might want to think about doing with this code, we'll push it, we'll put it on GitHub somewhere, and I'll put it in the episode notes. You probably find it on the you'll be able to find it on the Envoy Labs GitHub. There you go. And it'd be called "Here's One I Made Earlier" because I think that's what it's called.
That's what it's called.
That's what it's called. And the exercise here, I think, is to add an end type, which we mentioned we will find in env, and possibly also think about how you would stop people voting twice. So those are the 2 really, really obvious improvements you can do on this. Before we do questions, is there anything else you'd like to add on the code side of things, Callum?
Yeah, so what we've done here is, of course, we've just told you it works. In reality, we'd go and write unit tests and show you that it's working. But in an hour time slot, maybe we can do that next time. We'll write some tests and show you that it actually works. And on top of that, there's probably, as you can see, the contract might be screaming at us. As you can see in contract.rs on screen, there's 2 sort of lints. You'll want to get in the habit of running cargo format, which is cargo FMT, and cargo Clippy, which will just make you keep your code clean and will come up with a bunch of really helpful responses. Like there, it's telling you should underscore it because it's not used. So get in the habit of running those. This code, we haven't been running it, of course, but we'll probably clean it up a bit before pushing it. But throughout, you'll probably want to be running those.
Yeah, I mean, we probably won't clean it up particularly before running it because YOLO, we need something to do on future episodes. So we should, to be fair, the next one we should probably actually do tests. That can be we can come back and do the tests next episode, and then that would be lots of fun for everybody involved. Yeah, what's it complaining about? I don't actually see.
I don't see where this one is complaining.
It's complaining about something.
Oh, it's info in the actual root execute function because we don't actually pass info anywhere. So that actually needs to be underscored.
And now it's gone green. So there you go. Everybody's happy. Justice is restored to the land. So that's the code part done. I'm going to switch back over to the chat so I can see any comments, and that's going to cause the fun infinite window. So,
okay. It was only there for a brief second.
Pretty smooth, all things considered. Okay, so it's time for a few questions. So let's have a look at the comments and work out if we've got any other bits.
We handled mics.
We handled mics.
We can do it again. Just so it's
curious how we can use the schema files that have been created on the front end. QuickType is the thing to look into. That really helps with working with those. With those generated schema files in TypeScript. Callum is like GitHub Copilot on steroids. Very good.
It's actually all me. I am GitHub Copilot. Whenever someone installs it, I have to go. I've got a pager that goes off when someone needs help.
Whenever Callum talks about that internship, he couldn't talk about what he was doing. It was just working as a mechanical Turk for GitHub Copilot.
Please, I want to see my family again, GitHub.
Cool. Okay, and we've got, I think,
one from the sheet, which I can do because I'm not the host. So how do you get contracts to interact with other contracts? This is asked by Tuga on Twitter. That's probably me butchering the name. Notes, for example, I noticed the CW721 template doesn't allow users to mint NFTs. Just a quick overview, Sony hasn't looked into CW721 spec. By default, it has one minter, and only they can mint new tokens. So that means, and then he says, from my understanding, the assumption is another contract will have the logic to allow users to mint NFTs, and that interacts with the CW721 contract. So what he's describing is that you have another contract which sits in front of your CW721 contract and acts as sort of a message router that any user can send it to that contract, and then that contract is set as the minter to the CW721, and that'll then send the mint message across. And this is possible. You can have contracts talk to each other. You can even have them query each other. But there are the main way you do this is you can, on that response attribute, where we define the attributes, there is you can add messages, and these can quite often be your common Cosmos actions. So this, for example, could be you could send tokens to someone, you could execute another contract, and you can stake tokens, you can unstake tokens, all through this little message endpoint. And what Freya's shown is the API for a sub message, and this gets on to how you could say you wanted to send off an error, but you wanted to know if it succeeded or failed. You would use a sub message, and a sub message is a little wrapper which associates an ID with a message. And you can define it to reply always, reply on error, or reply on success. And that means you can handle each of those cases appropriately and detect them. And that brings us to our fourth entry point in CosmWasm code, which is the reply entry point, which is where those sub-messages are handled.
Yeah. So if you have, I think, as Callum pointed out, like if you have complicated behavior between contracts, you're going to be working with sub-messages quite a bit. But a lot of sort of more basic CosmWasm contracts and use cases. Actually, the biggest and most common one is probably you need to send native funds. And if you need to send native funds, the way you're going to be doing that is by putting a Cosmos message in and then adding it in as a message, right? And then it's dispatched with the rest of it. The other really common use case is querying, like Callum said. I mean, we have not to drop too much alpha, but everybody knows we're working on HAL, so whatever. There are a lot of interquery, intercontract queries in HAL, a lot. And that's probably our most common intercontract use case.
Yeah, and yeah, that's so contracts they're designed to talk to each other. As we say quite often in the first episode, we said one contract should do one thing, like one well-defined thing. So quite often you'll have these contracts doing their defined thing, but these contracts will talk to each other because they only do one thing. It's like on to the next step, which is this contract, on to the next step, which is that contract. So yeah, this is definitely sort of the main use case of contracts, that they can, all actually slot together quite nicely.
And the final thing I'll say on that is there was a conversation on I think Juno's Dev Discord a little while ago where people were asking about how to optimize contracts to be a certain size, because there are quite a few very commonly used libraries, for example, regex, that are very big. We've used regex in a number of our contracts that we've written together. And actually this morning I was doing some work to pull regex out of one of our contracts to make it smaller because it requires quite a bit of optimizing. And to Callum's point about doing one thing well, I think a future pattern for something like that, which might be better, is to just have a contract that only does the validations you need for your service. It includes the regex crate, because then it will probably fit under the size limit. And then all your other contracts can just call that, rather than actually having to worry about including quite a heavyweight library, especially if you want to do validation on Unicode, which is very important for non-English text. If you want to use, kind of any of the extended UTF-8 character set or Unicode, or emojis, which are also a valid form of communication. Anyway, on that, I think I am all talked out. So thanks very much for joining us. If you have any questions, Please do get in touch on Twitter or find us on Juno Discord or any of the other Discords we hang out on, DAO, CosmWasm, etc. We will be doing more of these, so suggest a subject of a thing you want to hear about, and we will do that. If not, we will probably do another one where we actually prove this contract works and show the testing, and I'll push the code up as is to the Envoys Discord before we do that as well, just so it's there. Okay, cool. Thanks very much, everybody, for joining us, and we'll see you next time.
Thanks all.